Uh, Good afternoon, everybody. As Mike was saying, I am the third Spaniard right now in the stage, and I'm going to be talking about maintenance and reliability. My first question for you is, do you own a car? Please raise your hand if you own a car. Exactly, right? Well, I own a car too. And the second question is, do you perform maintenance in your car? Yes, please raise your hand. Because if you don't do that, that's pretty bad, right? I became from hero to evil during this year. I have a diesel car, and I definitely have to perform maintenance. You know, with all the diesel that happen, with all the different things that happen with pollution, with all the restrictions now, my car has to be always spotless to be driving around. But let me tell you something. If you perform maintenance in your car, you are 80% of the times too early or too late. And why is this? This is because you're performing one of the oldest way of maintenance, which is schedule-based maintenance. So 18% of the times, you're actually correct and doing the maintenance at the right time. There's these three facts for this. First fact is that you go with your car, you get into the shop, you plug in, you put the logs, and they tell you your car is pristine. Your car is amazingly well. Why are you bringing your car to the shop? And when you do that, you're spending money. Because they're going to go with your check, and they're going to tell you, putting the machine in is $100. So you're losing time and money. The second thing is, you're changing parts earlier than you're supposed to. You go with your car, you get there, you have done 30,000 kilometers on the dot. And then what happens is that they tell you, would you like to change your tires? And you're like, sure. Would you like to change your brakes? Your brakes have 10,000 more kilometers, but would you change them, Ben? Yeah, of course. So you change your tires, you change the oil, you change your filters, everything, and you're using, or you will be able to use those parts a little bit more. So you're spending more money. Last but not least, how many times have you been driving your car? You go down the highway, you see that the counter goes to 30,000 kilometers, and you start hearing weird noises in it. And this is because you are a little bit afraid of your car breaking because they told you that every 30,000 kilometers or every year, you need to perform maintenance. Now, think of your critical operation assets. How many times have you been in your plant, going around, you see a pump, and you see the pump is vibrating, and you're like, I don't even know what's happening, right? Many times you see that. Or there's weird noises, and because you're not monitoring that sacked pump, you feel that maybe that pump is going to break. There are many different ways of maintenance. There's a reactive maintenance, so maybe there's a pump that explodes. There could be a schedule-based maintenance or usage-based maintenance. So you do a maintenance every year, you do a maintenance every 24 hours. So it depends of your asset, you're going to be maintaining it one way or another. It could be that you start doing condition-based maintenance, something that is very popular now. You look at your pump, you calculate your efficiency with all these different tools that, for example, Paulo was talking before, and you feel that your pump needs to be maintained every time that you cross the threshold of 75% of efficiency. Or you go even more advanced with advanced pattern recognition. We've been talking before, or during the day, in the keynotes, about all these advanced analytics, all this machine learning that people are doing, all this AI, right? Now, we want you to go from what it was before, a rush of having every morning to check all your assets and didn't know if your process was stopped or not, of going or receiving a 3 a.m. in the morning call and say, Carlos, your asset is not working. Please run in the plant because we're losing money. As a matter of fact, well, my name is Villanua Fernandez. I'm a systems engineer here at OSIsoft, and what I love is to technically help to understand the customers what is the PI system is all about and get the best value out of it. Before I became a systems engineer, I was a product support engineer. So what I did was I helped the customers to solve their issues, mainly with OSIsoft products. One time, this customer from Greece called me and he was having an issue with that with an interface. So those pieces of software that collects data. And I told him, you know what, let's restart the interface and see what happens. So I restarted the interface, sirens started to go. What happened was that there was an explosion in the plant, nothing related with my action. There was an explosion in the plant, and let's say a few weeks later, he writes me back, sorry, I have to go. Nobody died, no injuries, everything was okay. But he told me that the asset that exploded was not under maintenance, was not even monitored. So they have a lot of issues with that. And this is something that Greg LeBlanc was talking before too. All these pipe issues that we're having, right? So how do we fix this? By doing a monitorization, by monitoring our assets, our critical assets, knowing what happened, and having something automatized in order to prevent a possible anomaly. And your first question is, Carlos, where do I start, right? Well, let me start instead and tell you that normally what you need to do is start simple. Start with one of your assets. Start with one pump, start with one heat exchanger, one compressor. Start with small stuff that later on you can grow in. So for example, if I want to start with a pump, let's say I start with a little pump, and then I can grow to a pump station. After a pump station, I can grow to many pump stations, and finally compare all the pumps from my entire organization. So your first question, and I'm going to be using during the entire presentation examples of pumps. Your question when you get to the plant is, are all my assets okay? We can tell one, it's not okay, but all my assets okay. And the solution should be something like this. It should be a display that shows you every single asset that you need to report or that you need to control. In a simple way that you see if that asset really needs or not maintenance. Something like this, right? In this one, we can see that pump 03 is not performing well. It's in red, it needs maintenance. And why do I know this? Because the display in the back has some calculations, some analysis that allows me to know that, some logic in the back. So in order to finalize and get to that solution, I'm going to help you, and I'm going to cover 3 different sections. The first of all, I'm going to explain which type of maintenance we have, which options do we have, also which framework we're going to be using, which of course is the PI system. And then I'm going to help you to know which additional resources we have in order to perform this. Maintenance options. These options can help you in every single part of your assets, to any industry. But it's very important for you to know which one you need to use in which of your assets. Have you heard of any of these acronyms before? Yeah, I can see people nodding. Do you know which or what everything what is the meaning of those? Yeah, no. So this is my feeling every time I go to a customer site. Many times they throw me a new acronym and I'm like, did you just invent that? Is it something that you made up, or is it something that, because many times, this is in English, but many times they come in Spanish. And even though I'm Spaniard, many times I don't even know how to put the words together, right? So the first thing that we have is the RM, which is reactive maintenance. Then we have usage-based maintenance. Then condition-based maintenance. Then we have prediction-based maintenance. And last but not least, one of my favorite acronyms, which is actually not a maintenance, but is part of the predictive maintenance, which is advanced pattern recognition. I know you feel the rush, right? When you hear advanced pattern recognition, so cool. Let's start with the first one, reactive maintenance. Reactive maintenance could be as easy as changing a light bulb. Reactive maintenance doesn't work well with pumps or reactors, because reactive maintenance always helps when you have something that is not critical in your operations. Of course, I'm not going to be walking around the plant and saying, oh, that light over there is 95%. Let me change it now. And of course, I'm not going to be doing advanced pattern recognition to one of the lights. Then we have usage-based maintenance, which is, of course, based on usage. And this is something that you can actually calculate very easily with the PI system. What is it? Run hours? So it could be how many hours did the pump run? Yesterday we have a question from a customer. How do you integrate the installation date or the last maintenance date with the PI system? Well, we're going to come to that in order to calculate those run hours. It could be how many times the pump start and stop. We have a counter, easy counter with the PI system. Analytics is going to help you to do that in order to have a display that looks exactly like this. A display that is showing all these different metadata and the operational data and the things that we need to know, such as run hours, set installation time, or maintenance time. How important is also to have the metadata, that data that is coming from your maintenance systems. So you're not only getting the operational data, but as well, all that data from the maintenance systems. And if I go back a little bit and I look in the corner, performance scores. This is something that is going to allow you to know in which point your pump is running. Is it performing well? If it's not performing well, then you definitely need to maintain it. Condition-based maintenance. Easy to do with the PI system. So easy to do with the PI system. And I'm going to explain also how to do that. It could be, for example, cavitation events. It could be high vibrations, or actually high bearing temperatures, and then high vibrations. And you want to have something a little bit more extended than the displays from before, something like this. You have still your operational data, but you have a log of all these different events divided by the type of event that is happening. Of course, that pump is not doing well. You can see that it's having high vibration events, it's having cavitation events, and it's having bearing temperatures, high bearing temperatures. We had a question before from a customer in Paula's chat talk that she was saying, that they were asking, how do I put a reason code? If you look here in the event table, right there, there is a little click that says reason. So if you put there the reason that is happening, so you check there, maybe there's a high vibration events, and you see that maybe it's because of lubrication, you can actually put it. So later on, when you want to correlate all those assets, you can check how many times you had a downtime in your pump due to lubrication issues. So then you have to review maybe your checklist for maintenance, how your maintenance is being done. Think of that. I'm pretty sure right now you're thinking in all the critical assets that you have in your system, and if you're not maintaining it or not well. Now, predictive-based maintenance. This is what everybody's looking for. It could be an example of a pulverizer and seeing and looking for error detection. It could be, for example, predicting an engine failure. We have examples of those in our Pi Square. Our colleague Gopal and Keith, they've been working very hard to make this available for all the customers. Examples that you can see and you follow in the manuals. And last but not least, you can find anomaly detections in HVACs. Where do we see this? We saw it from Chris Nelson. He was talking about this before, right? He was showing all this information in his Pi Vision displays. Now, what is this? Linear regression. Easy function. I have customers asking me, I need to move all my data to this script in the cloud in order to do linear regressions. Well, the Pi system allows you to do that. So you can do linear regression with the Pi system. Something that Chris was mentioning before, Chris Nelson, is that what we don't do is advanced pattern recognition, but we enable all that data for you to be using it in other applications. This is why we have partners. All the partners are going to help you to enable all this stuff. Of course, you can do it by yourself too. An example of where you can use the linear regression could be in looking for the remaining useful life rule. I'm pretty sure you've heard also from this acronym. And how do we do this? I have an example. I could have placed all the AF structure and everything, but in order to be a little bit more simple, what I did was put in place some little trends that I draw. The first thing that you have is the hourly average efficiency, which you can calculate easily with the Pi system. Then, what you need to find is a linear scope. And how do you do this? I'm pretty sure there's data scientists in the area. I'm pretty sure there's people thinking right now, how do you do that? Well, you can do it with a normal algorithm. Logarithm. Natural logarithm, exactly. Okay? So now you have a linear slope. You did it with the pi system. And last but not least, the linear regression. A linear regression where you're going to place the threshold of efficiency that you want to have, for example, 75%, and you're going to be able to predict the remaining useful life. There is an example of this in our pi square, so if you want to find it, it's right there, with all the different equations that you need to use, everything configured. Then, what we were saying about advanced pattern recognition. What is advanced pattern recognition? It is a way of detecting anomalies before they happen. So it could be something like this. You have a prediction that you did it with your model. So you created a model. You have your prediction. You're sending data with your integrator into the cloud. And then you have all that operational data. And you start seeing deviations. You start seeing how there's anomalies. When that's not happening, it means that or your model is not correct or your asset is failing. So if we find deviations, that means that there is something wrong. And that can lead to a downtime, something that you don't want. You only want to have downtimes when it's time for maintenance. We have customers that they close down their entire industry on August, and they just perform all the maintenance. But before that, if you need to do tuning, you want to prevent that, and you don't have a long downtime. And after that, your pump is going to be perfect, and it's going to be working as expected. So in order to wrap up the different type of maintenance that we saw, first of all, reactive. It could be good for a light bulb. I would not use it for a pump. Second of all, it could be use-based. In pharma and in other industries, they have huge tanks. And those tanks, they only need maintenance maybe once a year. There's a guy that gets into the tank, cleans it, looks for any failures, they close it, and does it. Then, we have the usage-based. The one that could be, for example, for a pump. Easily. You see how many hours it's been running, and if it's okay, then you do maintenance or not. Condition-based, based on logic, based on rules, compressors, and then something more complex will be for predictions. For example, if you have a gas turbine, there's so many variables that are involved there that sometimes you cannot control. So you want something as a machine learning algorithm to be working with those variables and finding if there's going to be an anomaly. And of course, how are we going to do all this? With the pi system. I'm not going to be putting huge structures. I'm going to only put the little things that you need to do. And, well, pi system. You have seen this before. The pi systems enables a lot of use cases. It could be getting all that information into the infrastructure and then doing one of the use cases, which is the maintenance. There's different steps that you need to take. And as you see, they're very similar to the ones that Paula was saying before. First thing of all, connect and collect all the data. Data that is not only in your operational databases. There's also important data in other departments, in maintenance databases as well. That metadata that doesn't change too much, but needs to be in the pi system as well. Then, you need to assign a context. That context that is going to allow everybody in your enterprise to know what is the data coming from and which asset it is. Then, you need to execute a logic that tells you if that maintenance is needed or not. You need to alert or notify. But not only alert or notify people, you also alert and notify applications. For example, a CMMS. Maintenance applications. And last but not least, you visualize it in order to see what's happening. The first thing what we're going to do, one second. The first thing we're going to do is connect and collect that data. And this is not the easiest process because you have data in many different data sources. Sometimes in data sources that are not easy to connect, some little sensors. And this is why we created OMF. You've been hearing about that before. Or the Edge Data Store. All these tools that allow you to do that. But if you have a standard data source, we have 450 interfaces to help you to collect that data. And then you store it. You have your historian, you put all that data, all that raw data there. Now, I was saying there's different type of data. First of all, operations. The flow, pressure, temperature. Then you have maintenance. Date of last installation. When it was last maintained. Who did the maintenance? Who needs to be doing the maintenance? Which is the vendor? Serial number. And you combine everything into the PI system. And you have everything under your AF structure for it to be used for calculations and for contextualization. Then you need to build a digital model. We've been talking all the time about digital twins. You want to see your pump in a display reflecting as much as possible the reality. And this is also why you have your goggles to look at the pump and see what is happening there. Well, in here, this is the most similar to an AF structure. You create a template of a pump. Why are we creating a template? Because pumps are in all your organization. So creating one template, you can use all over your organization. And the best thing is that if you have different plants, all the different plants are going to have the same template in a way that you can compare all the assets with the same attributes and characteristics. When we see a tag, for example, pump status or discharge flow rate, those are operational data. And then you can have, for example, horsepower and total head, which are coming from the vendor. And with that information, we're going to be able to calculate the pump runout time to do use-based maintenance or the efficiency in order to do condition-based maintenance. So, suggestion, start small. Don't try to do all your assets at the same time. Just try it out. Go one by one, and then use pump stations and more. If you use Excel, who uses Excel in the room? I'm pretty sure a lot of people. Perfect. I love it. When you use Excel, you could do a macro, which is more complex, but every time you do a function, this is very similar to that. All the functions that you can in Excel and more can be used in the PI system. So if you want to calculate, for example, the efficiency, this is a very, let's say, easy function. You can make it more complex. Oh, I have the function for the efficiency of the year. You can make it, and you can use it in the PI system if you want. But this will help you to do with the flow rate, with the head and the horsepower, you can actually calculate what is the efficiency. And again, use a template. I'm going to say this over and over because I go to customer sites and they don't use templates. Every time you create one element, just do a template. It doesn't hurt. Now, the logic. We've talked about assigning context, and now we need to do the logic. A logic that is very easy to do. For you to maintain a pump, it is easy enough to do efficiency minus the 75%. But you could do, for example, if efficiency is less than 75% and bearing temperature is less than that, and it's been running for 200 hours, then do maintenance. And the configuration is as this. And you were saying, you could be saying, there is a lot of white noise in my sensors. So many times I see pics, and that gives me false alerts. Well, there is another amazing thing that is true for. So if you want to have the alert only where the event is happening for 10 minutes or 1 hour, then you do that. And this is very interesting, for example, when we have water reservoirs and those waves go up and down, and many times you see the sensor going up and down. So they actually put 2 hours, 3 hours, right? Again, use your template. Those were the self-serve tools from the PI system. But as we were saying before, we can integrate with other systems. We can integrate, for example, with, let's say, Azure in order to do the calculations. We can integrate, for example, with CMMS applications. So it is very important for you to know that we offer you a lot of tools for you to integrate. We use the integrators, but as Sergio was saying before, there is other ways. For example, the App API. And there is actually a booth that if you want to visit, Developer Technologies, go ahead, and they will tell you what is the best way of integrating your systems with the Pi system. So we want to get in, we saw all this information, but one of the most important things is to go back. And why is this? Because you don't want to create more data silos. You want to have all the information under the same roof, enable for you to be comparing that information. We start with an infrastructure with this OSIsoft, and these are the different examples where you can connect to. Before we were talking about having goggles, having glasses, having BI tools, so you can put all that information in different sources and you can access to it different ways. A few years back, we had a partner with a pump that you could just bring your tablet or your glasses and you could see how the pump was working. An example from one of our speakers that you saw it today, one of the keynotes, the guy from Sweden, he was talking as well as how they're using the glasses and connecting to people from France, and they can see how those pumps or those elements are working and which ones need to be changed. We can put the information in data lake and warehouses. And why is that? Because later on, we want to use all this information in order to put it in data science. When we talk about data lake and warehouses, it could easily be the OCS, the soft cloud services that we were talking before. And the machine learning and the data science could be performed by our partners. Again, very important. Feed that information that you have calculated back into the Pi system. When we talk about notifications and alerts, it could be that you want to send this information or those notifications to a person. So maybe you send it to Outlook. Or it could be that you want to send it to an application. So that application starts a workflow. We have customers that they don't really work with email. Why? Because they are remote. So they can do it maybe with a web service. The notifications are able to connect to web services via SOAP or REST, and then start workflow. For example, if you want to send an SMS, you could have a web service, and we have clients that do that. You can have a web service. The application of notification is going to send a message to the web service, and they're going to send an SMS. They don't have 4G, maybe in a jungle, or maybe in the middle of the desert. So they have GPRS, and they can connect to that with SMS. When you create an event, we have done the logic. There is a very easy way to connect and to create a notification out of that event. A notification that can send that information to the application of your wish or to, for example, Outlook. Again, always use templates, reutilize. As I was saying, again, beyond basics, use everything that you have in your power. Roberta yesterday was saying, if you have a Ferrari, but you only use it to chill in it, then it's no use. We have another customer partner that was asking me, Carlos, how do you connect to, for example, SAP PM? I have a web service. Can I use notifications? Of course you can. That way, you only have one piece of software to be taken care of. You don't have to create another script in the middle to send that information. Now, very important. All this information that you have in the Pi system, you can visualize it. We have seen examples, as I was talking, of the pumps, a display. We see little part of the display. All this information can be used, for example, in Pi Vision. In Pi Vision, you can have a display showing every single asset that you have, all the pumps, with some of the operational data. This is meaningful. At the end, you can see little red dots, little red areas that they're telling you there's something wrong in your asset. So you need to go to that asset and check it out. So if I click in that asset, I'm going to have another display that is going to englobe, is going to have all the different parts that I was looking for before. It's going to have all that metadata. It's going to have vibrations. How do you get vibrations into the Pi system? Vibrations are, or is data that is not normally in the, let's say, automation system because it was not needed to automate your pump. So what you do is you can connect sensors with maybe an edge data store and set that information, as I was saying before, with OSIsoft message format. We're talking now IoT. We're talking edge. Also, you can link it to a URL where you have, for example, your checklist. So if that pump needs to be maintained, you can see there, actually, you can see there, it says troubleshooting checklist. Sorry I didn't highlight it, but I'm pretty sure you can see it. If you click on it, you can actually access to a report with a checklist, and it's going to tell you how you can maintain that part. And as well, as I was saying, all the different events. Last but not least, we have also another way of using or reporting. This is something that Mike was talking also about yesterday. I'm not going to explain this display in detail, but I want to give you ideas. When you are doing events, you can explore and you can get all the information into a display in order to find correlations. You don't need to send this to a BI tool. Even with Excel, you can work with it. And later on, when you have a proper use case, you can export it to Power BI or Click or typical Spotfire, whatever you want. All these different tools that allows you to do that. And it's very important to use, for example, the recent codes. Because here, you're going to be able to filter by pumps, and you're going to be able to know how many times your pumps were in downtime doing or do it to a technical reason. I'm not going to show any displays with BI tools, but what I want you to have in mind is that we have the integrator that allows you to get all this data into different tools. It is very important to have before that data cleaned, contextualized. When you do, for example, an advanced pattern recognition project, you don't want to send 1 million points up to the cloud. For what? Many times they are not clean, they're not pretty, and you want to find magic from maybe a script. But those models need to be trained with the correct information. And this is why you have the integrator. Because all that data, all that logic that you have created, all that contextualization that you have done in your AF, you can send it afterwards that way. So we had 5 steps for maintenance. First of all, very important, you collect your data, then you assign your context, execute a logic, then alert and notify, visualize, and one that I didn't mention here, take action. When you have all the information, you can take action on your maintenance. Resources to help you. This slide was very similar to the Paula one. You have PySquare with all this information. If you put maintenance, you're going to find many documents that you can use. Or you can use the asset-based Py example kits, which have examples, for example, of condition-based maintenance of pumps. And very important, an ebook, a white paper, with the best practice that we have for condition-based maintenance. So with all this, you're going to be able to perform on your own. If you need help, there's also partners that can help you. Go to the booths. Go talk to them. They're going to help you out. They're going to let you know how they operate and what examples do they have. I'm not going to name any partner right now, but let's go around and look for them. Again, back to my example with the car. I am a regular user of the car. That's me, actually, with beer. This is 1 year and 2 days ago when I was getting married. So I spent my anniversary here with you guys, which is amazing. But what I want to tell you is that next time I take my car, I'm going to connect a little Raspberry Pi to my OBODV connector, and I'm going to be able to send with OMF all the information from my car into the Pi system. I'm going to calculate the efficiency, and I'm going to go to the workshop only when I need to maintain my car. Thank you very much. This is my information. If you have questions, you can write me here. If you also have questions, let us know. Oh, sorry. Somebody was taking the picture of the... Thank you. I can go here too. So you have my both faces. If you have questions, you can ask Mike. Or no, I'm kidding. You can ask me too. He's very good at maintenance too.
Hi, Tony Ellis from Arconic. You were saying about the reasons that you could enter the reasons in there. Can that be configured as a drop-down list, or is it just a free text field? Or
it's actually a drop-down list. You can click on it, and there's going to be a drop-down list. You configure this in AF as an enumeration, and you can click on it and then select which one you want to use.
Excellent, thank you.
Hello, Carlos. Grania Edwards, BMS. You were talking about an example of the data not in our control system on, say, a pump conditions such as vibration or temperature bearings. We've actually had this question from our maintenance group on site. So have you experience in fitting those? I'm just learning about the data edge and the OMF today. So have you examples on sites that have done that?
Yes, we have examples. And actually, we have a partner that I can present you to later. He's been working a lot, and he's been doing a big project with this. He's been connecting all the vibration from different pumps into the sites with the PyData archive and with the OMF. So we do have examples of that.
Yeah, that would be good to get that info.
Perfect. So let me know. I'll get your contact, and because I need to find the partner as well, because I know he's around, but for sure.